All right, hello guys. Uh, I think the contest is not over yet. Uh, we still have around 1 minute or something, right? Let me see my rank, by the way. It was 32. Yeah, so I think it will stay 32. Not sure though. Okay. Am I live, guys? Am I live? No chat responses. Okay. Cool. So, do you guys want to see my code for the last problem? Okay. The time is not much. I'm pretty sure you guys cannot write that much code in so less time. So I'm gonna show my code. Okay, so here you go. Okay, yeah, just kidding. Cheating is bad, right? So yeah, don't see anyone's code before the contest ends, right? So no matter what the test case is, cheating is bad. Okay, right? Uh, okay, so 3 seconds are left unless the contest gets extended, right? So uh, okay. Okay, okay, right. So in today's contest, I was able to solve around 5 problems, and it took almost all of my time. Like I could only do these fives, and I think this last one I did it in the last 8 minutes or something. 207, right? So I did the last one in the last 8 minutes. So I didn't even get a chance to read FEAT. So you can see that this link isn't even visited. I haven't even read it yet, but I was able to solve the first 5 problems. I would say that at least in the way I solved the problems, the implementations were difficult in this contest. I mean, like tougher than usual. I use C++. Okay, right. So you can see any of my codes. It's in C++. Okay, right. Flash the second solution. Uh, like no need to flash now. I'll be explaining everything. Right. So this looks something like this. I think it's just a brute force. I'll explain soon. Let's do one thing though. Uh, okay. So I think I should put my rank here. Okay. Rank 32, I think. FEAT Errichto. Okay, I'll write this when he comes, right? Okay, so you can see that he has written in his stream that he'll be joining us. So yeah, he'll be joining us in some time. We'll see about that. But yeah, so I'm gonna put rank 32 here. Okay, good. Right, so let's go then. Okay. Let me just make sure that this got edited properly. Okay, right, cool. Okay, so let me read the chat. Start the explanation. Okay, cool. Right, so this is the first problem, that is anti-knapsack, right? So a lot of you might be familiar with knapsack. It's basically something like you are given a lot of elements and you have to choose a subset of the elements such that the sum of that subset is equal to a given value or less than or equal to a given value, something like that, right? So that's what knapsack is. And here we have anti-knapsack. So in this problem, it's something like we are given two integers n and k, and you are asked to choose the maximum number of distinct integers from 1 to n, so that there is no subset of chosen numbers with sum equal to k, right? So what we're going to do is we want to choose some numbers from 1 to n. Okay, so like we have the numbers 1, 2, 3, 4 till n, right? So what we want to do is we want to choose some of these numbers such that like no matter what subset you form, the sum is not equal to k, right? And one important thing is given in the constraints, that k is not greater than n, right? So this is very important, that k is not greater than n, right? So k is smaller or equal to n, right? So it will be something like 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say n equals 8, right? So you will have something like this for n equals 8. And let's say k is smaller than n, right? So if k is somewhere here, then obviously you can pick all of these elements, because no matter what you add to these elements, it can never be equal to 6, because all these numbers are positive, and these numbers are already greater than 6, right? So anything that is greater than k, you will definitely include it, right? So I'll include 7 and 8. But what about all of these numbers? How many of these should we include? How many of these should we exclude, and so on, right? So what should we do? Okay, so in this case, we can see that if we pick this element, the sum will be equal to 6 if we pick this, and if we pick anything else, it will be greater than 6, right? So let's say I pick this, and I say that, okay, now I'll make sure I don't pick this. Okay, now if I pick this, and I already said that I won't pick this, and now if I say that I won't pick this either, then I know that 4 plus 2 is 6, but I haven't taken 2, right? And 4 plus 5 is definitely greater than 6. So I can take all of these elements that are greater or equal to half of this, right? So any element that is greater or equal to half of 6, right? So in general, if you have the k, and if you take all the elements that are greater or equal to k by 2, okay, so the elements that are greater or equal to k by 2, if you take all of these elements, and not greater or equal to k by 2, oh yeah, okay, exactly. If you take all the elements that are greater or equal to k by 2, now if you add any two of these elements, the sum will definitely be greater than k, right? So if you take two elements, e and f, and they are distinct, right? So e not equals f, right? Then what will happen is e plus f will definitely be greater than k, right? So you can take all the elements that are greater or equal to k by 2, and you can take all the elements that are greater than k except this k itself, right? So let me show my code. I did exactly the same thing which I'm saying right now. Okay, so I made a vector in which I'll store all the numbers that are possible, right? So I'll store all of them, and I take n and k as input. Then I run a loop from k plus 1 till n, right? So this is just a macro that I have defined in my code. This basically means a loop from k plus 1 till n. Okay, so I'm including all of the numbers from k plus 1 till n into my answer. And then after that, from k by 2 till k minus 1, I'm including all of them in my answer as well. Then I print the total number of elements that are present in this vector, and I print those elements in the next line, and I got accepted in this problem. So yeah, that was that. Okay. Okay. Which drawing tool you are using? So I'm using this tool called OpenBoard. You can see it written here. If the quality, if you're at 1080p, you will be able to see it here. That OpenBoard is written. Yeah, I'm using this tool called OpenBoard. Anyway, so okay, so I'm going to go towards B now. Yeah, so this one's actually interesting. Right. Okay. So yeah, so the implementation was a bit bad, but the problem was not bad. Okay, so it's something like these are the digits that are displayed on the like on a digital LCD kind of screen, right? And the important thing here is that 1 is present in the middle, right? So if you take the reflection of 1, it will be 1 itself. Okay, so what you want to do is you want to take the clock, and you want to take the reflection of this, and this thing that you get here, you want that as well to be a valid time, right? So if you have like 0511 here, and if you take the reflection here, you will get 1120, and let's say 1120 is a valid time, right? So it will be valid. Okay, so what's happening here is something like wait a second. So you have to first of all figure out which of these elements will be a valid element upon reflecting, right? So upon reflecting, 0 becomes 0, so that's fine. 1 becomes 1, that's also fine. Then 2 becomes 5, that's fine. 3 becomes nothing, right? So we have to ignore 3 and 4. Then 5 becomes 2, 6 becomes nothing, 7 becomes nothing, and 8 becomes 8, and 9 becomes nothing, right? So you have to make sure, you have to keep a track of which element upon reflecting becomes what, and so on, right? So this thing you have to do. And instead of having 24 hours in a day and 60 minutes in an hour, what's happening on this planet is that there are h hours and there are m minutes, right? But the input format is always HH:MM, and H comma M, both of them are smaller or equal to 100, right? So obviously they will never exceed your 2 digits, right? So what I did here was I just basically brute forced it. So in this question, what we wanted was it was written somewhere here, right? So for each test case, output in a separate line the nearest moment when the reflected time is correct, right? So we have to go in increasing order the immediately next moment, which will be valid even if you reflect it, right? So it is like obviously possible to see that the answer always exists, right? So let's see why the answer always exists. So no matter what the time is right now, we know that after some finite time, the time will become 0 0 colon 0 0, right? Okay. So since the time will become 0 0 colon 0 0 after some time, and since we know that if we reflect this, we get a valid time which is 0 0 colon 0 0 itself, right? So we know that the answer will always exist, right? And what are the total number of unique times that are possible? Okay, so this minute display can go from 0 till 99, right? And this R display can also go from 0 till 99. So since both of these can go only from 0 till 99, the total number of distinct values for the time are just 100 into 100, right? Which is equal to 10 to the power 4, which is basically not a lot, right? And considering that you only have 100 test cases, what you can do is you can try each and every time, okay? So you can just brute force it and keep increasing the time. And you need another function to check if a given time is valid or not, okay? So how can we check whether a given time is valid or not? Let's say we have to check whether 35 is valid or not, right? So to check whether this is valid or not, what we will do is we will see what the reflection would look like, okay? So the reflection would look like the reflection of this digit, then the reflection of this digit, then the colon, and then the reflection of this digit and this digit, right? Something like this. So first of all of these digits should be reflectable, right? And what I mean by reflectable is they should be either 1 or 0 or 2 or 5 or 8, right? Because any other digit cannot be reflected. So let me show you my code now. And basically that's what I did. So in the beginning, I made an array, right? So I have made an array and everything in this array is -1 except for a few values. And in this array, I'm just storing the reflection of that digit, right? So the reflection of 0 is 0, reflection of 1 is 1, reflection of 2 is 5, 5 is 2, and 8 is 8. Okay, so this I'm storing. After that, I take the inputs, the hour, the minute, and the like the total number of hours in the day and the total number of minutes in the hour. And then I take the string as input, the string that is the time, okay? And I used the C++ type input here, although it would be advisable to use scanf here because scanf would actually be better. You can just do something like, just input the format, but I used this C++ style input, right? So now I converted that string into the characters, and from that characters I'm getting the time. So I'm taking the first character, multiplying it by 10 and adding the second character, that is giving me the hour, and this is giving me the minutes, right? And now I have a function check a comma b, which is checking whether this time is valid or not. Basically, this check function is checking if we reflect a comma b, will it give a valid time or not, right? So what I keep on doing is, if this is not a valid time, I increase b, and then if b is equal to m, then I increase a, and right? So I'm like, if b equals m, then I'm making b equals 0, and if a equals h, then I'm making h equals 0. So basically this is denoting that the minute, the hour is changing, or maybe the day is changing, or something like that. So I'm just increasing the time one by one, and for each time I'm checking whether it is valid or not, and if it is valid, then I'm printing the time. Okay, so here I have used the C style printing, the formatted printing, right? So you can see printf percentage 0 to d. So this basically prints the integer always with the width 2, and if the integer doesn't have the width 2, it prepends it with 0, right? So if you have to print, I'll show you an example. So just a second. It's something like, let's say I have to print, I do printf percentage percentage 05d comma, let's say 34, right? So what it will do is, it will definitely print 5 digits, and it will prepend it with 0 if required, right? So you can see that it prepends the number with 0 whenever required. So that's what we wanted, to get the output in the exact format. Okay, and yeah, so finally this is the check function. This is how I'm checking whether the time is valid or not. Okay, so I'm checking all of the digits, both digits of A and both digits of B. They should be reflectable. If they are not reflectable, then I'm returning 0. That means this time is definitely wrong. So if there's any 3 or 4 or 6 or 7 anywhere in the number, then it is definitely wrong. Otherwise, what I'm doing is, I am reflecting the time and storing them as x and y. Okay, so I'm taking the last digit of B, multiplying it by 10. I'm taking the reflection of the last digit of B and then multiplying it by 10, and then taking the first digit of B, and so on. Okay, so this is just, you can figure it out on your own. Just draw it on the paper, make some arrows or something like that, then you can figure it out on your own. And this condition is important. Okay, so after we have taken the reflected time, we need to make sure that that time is a valid time, right? So for that time to be valid, x must be smaller than h and y must be smaller than m, right? So in the normal earth, the time can never be greater or equal to 60, right? So because whenever it is 60, like the minutes, whenever they are 60, instead of having 60 there, they will become 0, and the hour will get increased by 1, right? So I think that's clear. Okay, so you guys wrote the same thing but failed, right? So what you can do is, you can match your code with my code line by line, and maybe there's some difference there. Okay, yeah, we'll see that later. Okay, so now I'm going to go toward this problem C, right? Okay, so problem C was kind of okay, yeah. So in problem C, yeah, so it kind of kept me bugged for a lot of time. Like you can see, a lot of people who solved D couldn't solve C, right? Because C wasn't that easy. So let's see what it was. And it is non-trivial to see the trick that is being used here, right? So I used binary search here. I think I should add the tag binary search here, because I think most of the people must have used that technique. Okay, but I also know that there is actually a greedy solution also that is present, and that will work, but I won't talk about it because it is much more complex than the binary search, right? So we'll be talking about the binary search solution that I did here. Okay, so by the way, there's a video that I did earlier about binary search. You guys should check that out if you're interested in this type of special binary search, right? So let me just go to my channel, right? Okay, so you can see that I earlier I did this video, advanced binary search. I explained aggressive cows basically. So you can watch this video to try to understand how we use binary search in the solution space, right? So a similar technique is used in this problem in today's contest, right? So you are given a string s and also a number k, okay? And let's call a string beautiful if the string, if like the frequency of each character is divisible by k. right? So you want the frequency of all of the characters to be divisible by k, and you are asked to find the lexicographically smallest beautiful string. And lexicographically, like it should be lexicographically greater or equal to s, right? So you cannot have a string that is smaller than s, but if it is greater or equal to s, you want the lexicographically smallest such string. Okay, right. So now what you want to do is you want like a string is lexicographically smaller. So this is just the definition of lexicographically smaller. I'll assume that most of the people who are watching this right now understand this. And even if you don't understand, this is just basically the way in which the dictionary words are sorted, right? So then what we have is we have a lot of test cases, and then in each test cases we are given the n and k and then the string itself. Okay, so n is the length of the string, and then you are given the k and the string itself. Okay, so what's happening here is right. So whatever the k is, we want the lexicographically smallest string that is greater or equal to the string that is given in the input. Okay, so so I'll tell you directly how I thought about binary search here. So basically, I thought of it in some way that it's something like, okay, so something like if you have a string, okay, and you want to make another string, okay, so let's say this is the input string, the above string is like the input string, let's say just ABC, right? And this is the another string that you want to create, okay. So first of all, you are given a k, right? So if n mod k is not equal to 0, then it is definitely impossible. Okay, so this is the trivial case. Then it is definitely impossible, because what you want to do is you want to break the string into, like if you sort the string, you can break it into blocks of k, and all blocks should have the same character. Okay, so if n mod k is not equal to 0, then definitely it is impossible, right? But if n mod k is equal to 0, then you can see what we can do. Okay, so if n mod k equals 0, then the answer will always exist, because there is always one string that you can print z at all the positions, right? So this will definitely be a correct string, so answer will always exist. And now what we want to do is we want to find the lexicographically smallest such string. Okay, so yeah, let's see what we can do here. Okay, so for this, okay, so right, so what we want to do is we want to, like, till a certain index, we want to put everything the same as the above string, right? So let's say till a certain index, I place everything the same as above, and after that I can place something else also, right? That depends on me. So maybe I can put all z and so on, right? So till a certain point, I will place everything the same as the above string, and the problem is we don't know this point, like we don't know the point at which the first difference will occur, right? So what I'm trying to do is I want this point to be as right as possible, right? So I want that point to be as right as possible, because if I make the first difference here, then what will happen is the string will be really big, because the first character will be B. But if the first difference is here, then the string will be like really small and really close to the input string, right? So what I want to do is I want this pointer to be as right as possible, and for that I used binary search. Okay, so I used binary search to see the rightmost position of this pointer that is possible. Okay, and the checking function is kind of easy. Let's say if you have to check whether this pointer can be here or not, so what we have to do is we have to copy this entire string here. Okay, so we copy this entire string here, and as I said, the frequency of all the characters should be at least, like, should be a multiple of k, right? So we can count the frequency of all the characters, and then we can take the remainder with k, and we can see how much it is, how many more characters we have to put to, at least make it equal to k, to some nearest multiple of k, right? So we can calculate all that, and we can put everything towards the right, and anything that's left we can put z here, right? And all the characters that are left, we can put them in a reverse sorted manner, like B, B, A, or something like that, right? So we can do something like that, and in this way we can check whether it is possible or not. And whenever we get that this is possible, then we get the longest common prefix in the input and the output string. After that, we just have to change the next character. So we can run a loop from all the characters, like from A to Z, and we can see which character will be most suitable. Okay. So yeah, so that's what I did in this code. I'll show you, but I'll tell you one thing, that this was like not very easy. You can see even I made 2 errors here, and it wasn't very easy. Like the code was pretty long. At least my code was pretty long, maybe somebody wrote it in an optimized manner. But yeah, so this is definitely not very readable, but still I'll try to explain a little bit of what I'm doing. So I have nks, I take them input, and if n mod k is not equal to 0, then definitely the answer is impossible, and I return from there. Okay, then this is just a binary search up till this point, I think. Right, so yeah, up till this point it is just the binary search, and in this binary search I'm trying to figure out the last index till which everything can be same as in the input and the output. Okay, yeah, so that's what I'm doing here. And let's see, so I have a vector named put. Okay, so this is just storing how many more occurrences I have to put in the string t. And as I said, till the point m, I am copying the initial string only. Okay, so I'm copying the initial string till the point m, and I'm keeping track of how many more such occurrences of that character I have to put, so that it becomes a multiple of k, right? And then yeah, so I'm basically building that string that I described in the diagram earlier, right? So this code is a bit complex to explain. Maybe there is an easier way to write this, but yeah, this is not very easy. I cannot really explain everything, but it is something like I calculate the remaining characters that have to be printed, right? And then I calculate the number of characters that are neither remaining and nor printed already. So all those characters are z, and then I go in reverse order and print all the characters that are required, right? So the string would just look something like, let's say we have to print 3 A's and 5 B's, right? And some extra characters. Okay, so we have some portion of the string already. Then we print a few Z's, and then we print 5 B's, and then we print 3 A's, right? So that's what I'm doing in an elaborate manner. And finally, if that string is greater or equal to s, then I'm saying that yeah, we have found the answer. Otherwise, we haven't found it. So based on that, I'm doing the binary search. And finally, when I've done it, so I know that the unsert index will change. So yeah, I'm just running a loop on that to find the character that will take its place. And yeah, so it's kind of messy. Yeah, you can see the code is pretty long. That's the reason why not a lot of people were able to solve this. So yeah, the implementation was a bit difficult. What do you guys think? Did you guys think that the implementation was not that easy? What you did binary search for? As I said, I'm binary searching the position, the last position till which I'm binary searching the longest common prefix of both the strings, the input and the output string. Yeah, it wasn't that easy. Okay, it was like really complex. At least that's what I felt in this contest. Okay, so now problem D is going on. Problem D is not segmentary. Actually, it is Nadeem Sheikh. You didn't use binary search. Did you use a greedy approach or something like that? Okay, right. C was annoying. Yeah, C was annoying. Yeah, I agree. Like the idea wasn't that difficult, but to implement it was a bit cancer, I would say. Okay, right. So now we are at this problem D. After this problem, I think Errichto was going to join us, but let me see. Just hold on a minute. Okay. Yeah. So I'm not recalling you guys. I just wanted to put a joke on the screen. So yeah, that's pretty much a rickroll, but still, it's fine. Okay. Okay. Wow. Right. Cool. Errichto is saying he can join us for F. We'll see about that. Okay, so just got a word from Errichto. He said that he'll join us for F. So till E, we're on our own. After that, Errichto will join us. Right. Okay. Cool. So this was problem D, GCD on GCD of an array. This was not a segment tree because I think it would be it will give you memory limit exceeded with segment tree, I think, if you try to do something like that. But anyway, so you are given, like, the idea here was like very, very simple. It was like very trivial. The implementation was a bit tough. Not tough, I mean, like the implementation was the only thing that was there, right? So apart from that, everything was pretty much easy. Okay. So this was the problem D, GCD of an array. So you are given an array and you have to process q queries. In each query, you are multiplying a certain number to a given value. Okay, to the value at a certain index, you are multiplying a certain number. Okay, yeah, that's what you want to do. And after processing each query, you want the GCD of all the elements in the array. Okay, so for that you need the definition of GCD. So the GCD. Okay, so not exactly the definition, a trick about GCD. It's something like if you have a lot of numbers whose prime factorization looks something like this: p to power a1, p2 to power a2, and p3 to power b3. Sorry, p2 to power b1, p3 to power c1, and so on. Right. So you have one number like this, and then you have a few other numbers like let's say in the other number also you have p to power a2, p2 to power b2, and p3 to power c2, and so on. Right. So in all the numbers you have something like this. So the GCD will be the minimum of all these exponents and something like this. Okay. So the GCD will be something like the minimum of I think a1 comma a2, and you have to put p1 to power the minimum of GCD, like p1 to power minimum of these two things, multiplied by p2 to power the minimum of these two things. And if you had a lot of elements, you just take the minimum of everything, right? So that's what you want to do. You want the minimum of all the exponents for all the prime factors. And yeah, so basically that's the idea, and you just have to implement this smartly. Okay, so in this problem, there's nothing there apart from the implementation. So I won't go into much detail about the implementation, but there are a few things that will be helpful here. First of all, there's this thing linear sieve, which stores linear sieve basically, linear sieve will be helpful because it basically stores the prime factorization of all numbers. Okay, prime factorization of all numbers. Okay, till a range. Okay, so till some capital N. So you can choose the capital N, and it works in ON time. In linear time it works, and it can store the prime factorization of all the numbers till N using linear sieve. I'll tell you a little bit about the linear sieve just in CP algorithms. I also taught linear sieve earlier in an academy, I think. Yeah, I did teach that during the number theory thing when I was teaching that. Right, so this is the code for the linear sieve, and if you copy paste it like I did today, you can get the prime factorization of all the numbers till the capital N, whatever your capital N is, right? And okay, yeah. So you can see that beside this algorithm here, calculate the prime factorization of all the numbers as a side effect. Okay, so we don't want the side effect here. We want the actual thing. Like that's what we want here. Okay, and then once you have the prime factorization of all the numbers, then you can just keep a multi-set to keep the occurrences of that prime number in all the numbers. And yeah, so that's how you can do that. So I think that the tag is pretty much correct. Data structure, brute force math, because exactly that's what we're doing here. So again, the implement, like in this problem, there was no idea there was just implementation. So yeah, I have a map, I have an array of maps, then I have a multi-set of an array of multi-sets. Then yeah, then this is the linear sieve. And yeah, finally, let's see what I'm doing here. So I take all the elements as input. I take their prime factorization, and yeah, so this is kind of not very pretty to see, but yes. So basically, I'll just explain what I'm doing here. So let me copy this code so I can write some comments on my subline. Okay, right. So let me just explain what these things are. Okay, so we have a map of A. Okay, so A of x comma p equals exponent of p in A, in the xth number, right? So in the xth number, or let's make it I. In the ith number, I have the exponent of p, and p is prime. Okay, so only for prime numbers I'm storing this. P is prime, right? and this is a multiset in which I'm storing basically in mn of p, where again p is prime. Okay, so again p is prime. Okay, I think this much hint would be enough. So if p is prime, then in mn p I'm storing um, all non-zero. I'm storing all non-zero AIP. Okay, for all I. Right. So if it is non-zero, then I'm storing it in this multiset. Right. So yeah. So basically, I'm just trying to maintain this multiset all the time, so that I know the minimum element in that. And yeah. So one other thing that I had to do was, if the size of this multiset is not n, so like I'm doing whatever I'm doing, like I'm increasing the answer only if the size of this multiset is equal to n, right? So if the size of multiset is smaller than n, so like this is an important thing. So I'll just write it here in a multi-line comment. So if the size of MNP is smaller than n, right? So if the size of that multiset is smaller than n, then like definitely the minimum exponent of p is 0, right? Because in some number, like, because like I'm storing only the non-zero AIP, right? So definitely if the total elements in this multiset are not n, then definitely the minimum exponent is 0, and we don't have to multiply that to an answer, right? So basically I'm just storing this multiset at all times whenever we multiply something, whenever we take the input and so on. I'm just trying to maintain this multiset, like I remove the occurrences of p from the multiset, and then I increase the occurrence by 1, and then I insert it back, right? So this was just implementation and nothing else. Errichto commented. Okay, you can join for F. Oh, so you're watching. Nice. Okay, so Errichto is watching. By the way, if you're still watching, can you also let me know on what platform we will communicate during the stream, Errichto? Okay, thank you. Okay, so finally the problem E that we have at our hand. Neil also commented. Oh, hello Neil. Couldn't see your message here. Okay. Let me see the standings again. Did the system test complete? So did I? Okay. Right. So I didn't fail any problem. So that's a nice thing. Okay. Cool. Right. Okay. So we're at problem E now. And right. Let me see the chat as well. Google Meet is fine. Okay. Cool. Yeah, I'll create one soon. Okay. So let me just do this problem quickly. Problem E. Okay. So problem E was actually, like, the observation here was kind of difficult, but once you observe that, like it's really easy to solve. Like it's really easy to solve once you observe the thing that I observed. And actually, I want to see the codes of some other people for this problem. I want to see if they did the same thing or not. So Neil is rank 1. Let's see his code. Okay. Yeah. So this is definitely something else. Yeah. Oh, sorry, not F. I wanted to see problem E. Okay. Yeah, I'm not sure. Maybe this is the same as my idea. Yeah, maybe. Anyway, let's see. Okay. So here it's something like you are given two numbers L and R in the binary representation, right? So you have L and you have R, and you have them in binary representation, and the width of the number is like a lot. So it can be like up to 10 to the power 6. So that's really a lot. And let gx be equal to the bitwise XOR of all the integers from x to y inclusive, right? So what's happening here is, just a minute. Okay, right. So what's happening here is, we're taking the XOR of all the elements in a subarray or something, not a subarray, like a contiguous range, something like that. So from x till y, all the conjugated numbers, we're taking the XOR of all the numbers, and FLR is the maximum of GXY satisfying this thing, right? Okay. So like between L and R, we want to choose two numbers, and we want to take the XOR of all the elements between those two numbers inclusive, right? So, and we want the maximum value of that thing, right? So most of the things I realized from this. What program is using for drawing? I'm using a software called OpenBolt. Okay, so basically I realized these things from the samples itself, but another trick kind of helped me here, that thing that I knew. Okay, so first of all, if you want the XOR like this, x XOR x plus 1 XOR dot 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 y minus 1 XOR y. Okay, so you can use prefix XORs to kind of optimize this. You have just two elements. So let's say let's call prefix of some x equal to 1 XOR 2 XOR 3 and so on till the point that you reach x, right? So if you use this thing, then the above statement becomes a little easier to write. Okay, so it becomes something like this entire thing, this becomes equal to nothing but the prefix of y XOR the prefix of x minus 1, right? So yeah, that is kind of helpful here. Okay, cool. So yeah, that's kind of helpful here, and let's see how we can use this. Okay, so we have to focus on this prefix, right? So we have to see what a prefix like prefix of y would look like. Okay, so the prefix of y is nothing but the XOR of all the elements from 0 till that number. Okay, so let's see how it varies along with x. So for 0 it is just 0, for 1 it is 1, for 2 it is 3, for 3 it is again 0, and then for 4 it is 4, then again you have 1, then you have 7, then again 0, and again 8, right? So in general the pattern is something like it keeps on changing in this way. So you always have n, 1, n plus 1 and 0, right? So this pattern is repeating all the time, right? So if the number is a multiple of 4, you get n. If it is like if the number mod 4 is equal to 1, then you get 1. If the number mod 4 equals 2, then you get n plus 1 and so on, right? So you get something like this. Okay, and we're going to take advantage of this thing, and let's see how we will take advantage of this thing, right? So we can see that if any number ends at something like this, so let's say any number ends like whatever that number is, we don't care, but if it ends at this thing, if it ends at 1 0, right, then the prefix XOR of this thing, would be equal to the same number with the last bit 1. Okay, so this will be equal to the same number, but the last bit will become 1. Okay, right? So let's see how we can take advantage of this thing. So it is something like, let's say whatever the number in input is, we have the L and the R, right? So let's say the R looks something like this. Okay, whatever, it doesn't matter what R looks like, but let's say L has the first bit 0. Okay, so the L has first bit 0, and everything else, whatever it is, I don't care, can be 1 0 1 0 1 1 1 0 0 1 or anything, right? So I don't care what else there is, but if the first bit is 0 and here the first bit is 1, right? So I can do one thing, and that one thing is I can take these elements, like I have to take one element that is greater or equal to L, and I have to take one element that is smaller or equal to R, right? So I can take these two elements, this element and this element, right? So if R has the first bit 1 and L has the first bit 0, then obviously we can take these two elements, and we know that these two elements are consecutive. And if we take the XOR of these, then obviously it will be equal to the, like, all the bits will be set, and this is definitely the best answer. So we cannot do better than this, and this will definitely be the best answer. Okay, so this will be the best answer, and there's nothing better that we can do here. Okay, cool. So that's the best thing that we can do. So let's see, if this is not the case, then what we will do. Okay, if this is not the case, then there are only two things that can happen. So the one thing could be both L and R are 0. So obviously this is a trivial case, which by the way I missed, but this is a trivial case. For this the answer is 0. Okay, so yeah, definitely the answer is 0 here. But apart from that, there is another case. For that case, it is something like L also starts with a 1, and you have something in the right, and then R also starts with a 1, and then you have something in the right. Okay, then let's see what we can do. Okay, so we will take we can observe one thing, that if we take both x comma y equal to R, then definitely answer will be equal to R. So we can say that since we have one way of getting R, so we know that the answer is greater equal to R. Okay, so we know that the answer is greater equal to R because we have one way of getting R. So if we can get something better than R, then we will consider it, otherwise we won't consider it. Okay, so if you look at the numbers that the prefix XOR looks like, so it just looks like n1, n plus 1, and 0, right? So let's say if we pick the last element as this or this, right? So we can pick the second last element as this or this, right? So basically, if we put, like, if we have both x and y, right? So y can be of the form this, or this, right? So we know that it is useless to have this or this, right? So obviously y will be either of this form or of this form. Okay, and then x can be of all of these four forms, right? And then if we take x as one of these two, then obviously we will lose the more significant bits, so we won't do that, right? So the answer will definitely be either R or R plus 1. Okay, this might be a little confusing, but yeah, so that's the result that I got here, that the answer will either be R or it will be R plus 1, right? And this can only happen if R is even. Okay, if R is even, then only we can have R plus 1, because if we take XOR with 1, then like if we take XOR with 1 of some odd number, then the bit turns off instead of turning on, right? So obviously we want that thing to be okay. So obviously we want our R to be I think, like, if it is odd, then we will just print R because R will be the answer. But if it is even, so then R plus 1 might be the answer. Okay, so now we just have to see how R plus 1 can be the answer. Okay, so we can examine it a little bit. So let's say whatever the number is, if it ends at 10 or it ends at 100, okay, because no other case is there, because if there's any other case, it will definitely be odd, and as I said, for odd the answer is R itself, right? So for even, we can either have it end at 10 or we can have it end at 100, like 10 or 100, right? So we can have one of these two things. Okay, so yeah, let's see what we will do in both of these things, right? So for 100, what do we need to get to the last bit on? Okay, because we cannot get the second last bit on, we can only get the last bit on. Okay, so let's say whatever there is until the in the left of the number, if we have 100 here, then we can take the previous two numbers, which will look something like dot 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 011 and dot 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 001. Okay, and if we take the XOR of all three of these numbers, we can see that none of these ever changed, so this will be the same, right? So this won't change. This is 1, this is, oh sorry, this is 10, right? So this is 0 and this is 1, right? So we want the gap between this number and this number to be at least 2, right? So what I want is I want r minus l to be greater or equal to 2, right? So this is important. We want r minus l to be greater or equal to 2. And another thing that we want is, so this is the case when we have this case. And if we examine this case, you can make the same thing here and you will realize that in that case also you want r minus l greater or equal to 2. Okay, so you can make it on your own. You can make it something like 0, 1, 0, and then again you will have sorry, right? So this ends at 1, 0, then this ends at 0, 1, and this ends at 0, 0. And if you take the XOR, all of these are same, and this becomes 1, and this also becomes 1, right? So, right. So basically that's what you want. If r is even, you want r minus l to be greater or equal to 2. Yeah, so that's what I did in my code. I'll just show that to you guys. Okay. This is the problem. Okay. Let me paste it here so I can show it properly. Okay. So first of all, I did something like, I think this step was not necessary, but I still did it. But anyway, okay, from here. Okay. So I'm just seeing what the first one is in the L. Okay. So first one in L, in the string L, I'm taking the first one. Okay. And if that is not 0, okay, so okay, this was pretty useless. We could have done something like, if L0 is not equal to, if L0 equals 0, yeah, so we could have done something like this. So that's the same thing. Okay. So if the first character of L is 0, then our answer is just 1, 1, 1, 1. Okay. So then the answer is 1, 1, 1, 1, as I explained earlier. And okay, so if that is not the case, so if the number is odd, okay, so if r is odd, then obviously answer equal to r itself, right? And then I'm calculating the gap. So this gap is r minus l, but I don't want it to be greater than 2. Okay, so I'll just do it only 2 times. And basically in this loop, what I'm doing is I'm subtracting, like this entire loop is just doing nothing but L minus minus. Okay, so in this entire loop, I'm just doing L minus minus by moving from the least significant bit to the most significant bit, taking the carry and taking the borrow or something like that. Right, so that's what I'm doing. And I'm increasing the gap one by one. Okay, so if the gap is at least 2, then I'm printing everything from R except the last digit as 1. And in this, I'm just printing R. Okay, so yeah, that concludes the problem E. Now we're going to move to problem F. Can I invite Errichto now? Is it still watching or should I message him? Okay, so Errichto is going to join us. Let me. Okay, I'll change the title when he's already here. Okay, you're here. So let me just go to my waiting screen for a bit so I can, create a Google Meet so that you can join it. Okay. Hmm. He will be joining in 18 minutes. I'll send him the Google Meet invite regardless. Okay. So yeah, now we wait. And right. Okay. Hi, Errichto. Okay,
Hi,
nice to have you
how
here.
are you?
Okay. Right.
Everything is working?
I think let me ask in the chat. Okay, cool. So let me just put FEAT Errichto on my stream. Okay. Right. Okay. Hi. So did you attempt the contest? I didn't see you in the standings.
Maybe I was just that low in the standings. And now I've just read the last two problems.
Okay, and you were able to solve both of them?
I didn't think about details for E. It seemed reasonable what to do. For F, first I came up with some wrong heuristic. Not heuristic. I skipped the condition about disjoint rectangles.
Oh, I haven't read
Do
the
you know the
problem yet.
problem? Did you read?
I haven't read the problem yet. Actually, I solved E during the last 7-8
Everybody
minutes.
is saying that there is echo.
Okay. There is echo? Okay, yeah, there must be echo from my side. I get it. Okay. Right, so I should put on earphones just a minute. Errichto's mic is not correct. I think it was a problem from my side because I was on speaker and I have the desktop audio as well. Right, so that's why I think it was happening. Okay. Yeah, I think it should. Okay, so is the echo gone now? Errichto, can you speak something?
Yeah, sure, I'm saying something. Sound test.
Okay. Can anybody let me know in the chat if it is echoing still? Uh, Still echoing? Why?
Still echo.
Like it shouldn't happen. Okay. Okay, I get
When you're
it.
saying something, you can see what bars over there in your
Yeah. Actually, what was happening was my earphone is somehow transmitting both of the voices. I think now it is fine.
Okay, so
Yeah.
everything fine now?
Yeah. It was a problem from my side.
I can tell you problem that.
Okay, so
and I also can tell you how I use.
okay.
Should I show my screen?
Yeah, sure. But what do I do about the fact that people can see this link to this Google Meet on the screen?
It's not that they can. From time to time, you might get pop-ups. Somebody will ask that they want to join.
Yeah.
Maybe if you go full screen.
Yeah. Is there a setting by which I can deny everyone permanently?
Maybe you need to create a new meeting. Settings. I don't see that in settings for people. Create a meeting. Or set up a new meeting and do it as invite only.
Okay.
And then that shouldn't matter. I will give you one code.
Can we do the screen share on your Discord?
Anybody's Discord?
Yes, I am on your Discord already.
Where can I do it? Right? All right, I'm sharing my screen on Discord.
Let me open Discord first.
But I can also share in Google Meet.
Yes, but I think we should end the Google Meet because Yeah, people keep on trying to bug us. Mm. So I'm going to leave this Google Meet and we'll just talk on the Discord. Okay, is that fine?
Okay, fine. I'm saying something, I don't know.
Yes, I can hear you. Yes, and I can see your screen, which
I don't know.
you cannot hear me.
Okay, my bad. Now I hear you.
Okay, okay, right. Okay, so I can see your screen, but I think this is just your wallpaper. Okay, yeah.
I tell you I tell you how I misunderstood it. The problem is interactive.
Can we have your face cam also somehow? Like if you just turn it on Discord, then we'll be able to see it. Yeah, yeah, okay, yeah, that's fine.
There is a rectangle, and you know its height and width,
Okay,
both up to 1,000. Limits are up to 1,000, but you don't know the elements. This is an interactive problem, and you need to keep asking: are some two rectangles the same? Like you put some coordinates of two rectangles of equal sizes, and you will be given information yes or no. And you can ask logarithmically many queries. There is a statement,
okay,
and you need to figure out this: how many ways there are to choose some rectangle size, so that you could repeat this all over the grid, and all those rectangles would be the same.
okay,
So they need to follow some same pattern. As a sanity check, for sure the rectangle height here and rectangle width must be divisors of corresponding height width of our grid.
okay,
And you can just ask queries like this. So are those two the same? But we are allowed logarithmically many queries, so you cannot do that. With brute force. And there is additional condition that you cannot ask about overlapping rectangles.
okay.
This is forbidden query, and I thought that it's allowed, and then problem is much easier.
Okay, okay, okay. So like the intersection should be 0 between the two rectangles, right?
Yes, exactly.
Okay.
The chat is saying that my voice is low.
I think I fixed
right
it.
Click on me on Discord.
I think I fixed it already. Is it still low?
You can right click on me and slide it up. Like 3 different people said it's low. Maybe now it's better.
I think it should.
So you can solve the one-dimensional version. You're given a string and you need to find how are those called? Periods. You need to size by asking queries: are two substrings the same? Like, is this the same with that? You can ask, for example.
Okay.
And in logarithmic time, you need to find all such periods of the word. You can think about it now, I guess.
Okay, so we have around 3 log n plus m queries, I think.
Yes.
Yeah, and it's a big rectangle. What exactly do we have to find?
All the periods. The number of periods. So how many lengths there are. That for a string, that would be how many lengths there are, such that if you split into blocks of this length, then everything is repeated. For example, if it's ABB, 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 and let's say that's it.
Okay.
And maybe I want one more. ABB.
Right.
And there's period of length 3.
Okay.
And also there's period of length 6.
Right.
So the answer is there are 2 non-trivial periods.
Okay. And it's a string. I think I think I know something about this. Like the first thing that comes to my mind is to use something like prefix function, the one that we use in KMP, and
Mhm. But all of that is linear.
okay, yeah, right.
We cannot even go character by character.
Right. So, by the way, how do you have a single row? There are a lot of like the
Oh, I'm
problem.
just saying that this is some simpler version of a problem that you can think about now.
Like
Because
there's a single row
I
here.
don't think it's possible to solve this problem in 5 minutes, like the full problem. So I'm
Okay.
giving you a subtask and then I will talk about the full
Okay,
solution.
okay. So you just put m equals 1, right?
Yeah.
Okay.
And try to then achieve then like 3 times the logarithm.
Okay, and the query will just be a sub array or something like that now because
Take 2 sub-array of
that
sub-arrays
are
equal size. They must be disjoint.
disjoint, right? And okay,
it's good to start with particular period and how to do it faster than linear time.
right.
In particular, check if there is period of size 1. So check if all characters are the same.
Okay, I'm trying to read the problem again. Actually, I kind of forgot what do we get in the result to the query.
Yes or no if the 2 sub-arrays are the same.
If the 2 sub-arrays are the same, right? Okay. Yeah. So
you provide 2 values like L1 R1
and L2 R2.
L2 R2.
And if these two are the same,
you
then
need to satisfy this.
Okay.
And lengths are the same. They must be the same lengths of this and that. You're given yes or no as the.
Okay, and we want to get the total number of periods such that. Okay, so I think there's something like you'll have a smallest period and then all the multiples of it such that they kind of fit in the entire array. They will be also valid periods, right? Like we have 3, then we also have
something like that is true. Yes.
Yeah, so we have 3, so we also have 6. I think 9 is not correct here, right?
Yes, 9 doesn't work.
Okay, 9 doesn't work. I think.
But all those, they need to be divisors of 12.
Yeah, divisors of 12, right, exactly. So we want to find something like the smallest period or something like that, and then everything else has to be a divisor of that. But how do we find the smallest one without considering everything? I mean, for example, let's say all the characters in this are just A. Then how do we know that everything is A without? Okay. Yeah, it might be possible. Right. Okay. So you're gonna show a lemma.
I'm just writing down what you said.
Okay.
You're on the right track.
Right. So we're gonna just find the smallest period. Yeah. I'll just say one thing. I have never been so much pressurized while doing the problem during competitive programming. Like I'm doing it with Errichto himself. Yeah. Okay. So let's see. Okay. So maybe something like. Very sure. We have to find the smallest period. Okay. The smallest period definitely cannot be greater than the half of the string. Okay. So. Maybe I think the half of the string will always be one of the periods. Otherwise, it is not like. Otherwise, only the entire string will be the period. Okay, no, it's not correct. It's not correct. Maybe like we can have 9
in
and 3.
In particular, this smallest period can just be of length 12.
Right.
This is always a period.
Right. Or we can have right.
You can think just about this because this is a nice problem as well. How to check for period equal to 1? No,
that's simple to check for period equals. Oh, for period equals 1 with the disjoint subarray. Like if it wasn't disjoint, I could have done something like the like 1 to r minus 1 and from 2 till the r. Right, something like that I could have done.
Yeah. And I thought during a contest that we need to do this. just compare them. If it's equal, it means that those two characters are equal, those are equal, and so on.
Yeah.
But
if it's disjoint, that's really difficult, I think. Okay. Right.
And instead, we need to do it in logarithmic time.
And we still have to do it in logarithmic time. Wow. So this is definitely a much easier subtask to the original problem, and I'm really getting stuck here only. Maybe we can just go over all the prime factors of that thing and do something from that. I think that should work. Something with all of the prime factors of the number, because they are also logarithmic.
What about this? If you know that the complexity is logarithmic, you can go and try to split the string into two parts.
Two parts?
That usually creates a logarithm. So if this is length 10, what if I split here?
Yeah, there's one problem with that. Like if we had something like 18, right? So we could have the period as 6. So if we divide it into two parts, we'll divide it at 9 and 9, and maybe.
I'm still talking about this.
So period 1.
Checking for period 1.
Checking for period 1. Okay. So yeah, so then that's trivial, because we'll divide it into two parts and then check if both are equal, and then we'll keep on dividing it into two parts recursively. Yeah, then we'll get it.
Exactly. If n is odd, then we need to compare, like here for 11, we compare to 5s, and then we go recursively here, hence the complexity is log of n ceiling complex.
Yeah.
Like that.
Yeah, okay, so that's how we can check for period 1, but like if you have to check for any other period, I think maybe we have to do...
For periods like x, you can just do the same, but it will be n over x. I mean, when we're checking for period x, just take like x consecutive values, we say that this is one block, one block, and we do the same.
Exactly, yeah, we can do that. But we cannot keep on checking it for all the periods. I think that will be disastrous.
Yeah. So now I will tell you the magic from the full solution. But yeah, you solved this thing. So that was something, because of misunderstanding the statement, I struggled with doing the contest.
Okay.
What do we have here? So I think it's useful to prove this lemma. And actually, this lemma, it consists of, I would say, two sublemmas.
Okay.
And one part of the proof is that if x is good period, then I mean block of size x is good period, then also 2x multiples are good.
Multiples are good. Right. Multiples that fit.
What did I say? 10. Multiples of x.
All multiples that fit.
Yeah. If multiple of x is also still a divisor of n, then it's good. Something like that. Right? Yeah. Like if length 3 is good block size, then length 6, 9, and 12 also will be good if they are divisors of n.
Yeah.
And second is something like that, but this is more crazy. If x and y are good, then GCD of x and y are good. This is actually a reason why smallest period is enough.
Yeah.
And this is the thing with strings, that if 4 and 5 are good, they in some way interleave.
Exactly.
Okay. So from this, there comes a solution like that uses something like this. If we know that, let's say, x equal to 3 to some power times 5 to some power.
Okay, you have the entire prime factorization.
This is good.
Then 3 and 5 are good.
What about this? We need to check if this is good.
Okay.
Then I find some multiple of x, like the next multiple, so the smallest next number, like this, and it's like that. If this is bad, then I already know that this is bad. I mean, because of lemma 1, that's the easy part, doesn't matter. And now if this is good, and cool thing is that we just need to check for the divisibility between them, for actually the ratio between them.
Okay.
And we need to check this for like 3. And why is that? Because we know that big blocks of length y are good,
Okay.
and now we want to know if smaller blocks of length x are good, and x is 1/3 of y,
Okay.
like that. There are more y's possibly. Then, because we know that y's are the same, and here
We have
it's
to
enough to just focus on
check
one set
on
of
one of
x's.
them. Yes.
And we already described how to do this in log of 3.
So wait a
Seeing.
minute. So wait a minute. Will it be a summation of logs, and that will be just the log?
Yeah,
Okay.
exactly.
Okay. Yeah. That's a pretty interesting
The
result.
final complexity turns out to be sum over ceiling of log of p, where p is every prime factor of a number. If n is, let's say, 2 times 3 times 3 times 17, then the number of queries we ask is log of 2, that's log of 3, plus log of 3, plus log of 17. All of that's taken with a ceiling.
Nice.
So the ceiling is a little bit of problem.
But we are given
ceiling
3 times. We are given 3 times something. So that's fine. Yeah.
So I guess the exact analysis is a little bit difficult because you would need to say how much this can be increased because of that, and like the case with freeze.
I think this is easy. I think this is easy. I think it will just be 2 log n at most. This is bounded by 2 log n because at each element we are adding at most 1, and they are just log n terms here, right? So yeah, because like if
2 log n.
Like if the ceiling wasn't there, it is definitely log n.
But this I think is too much. That can be greater than 3 times logarithm of the sum.
Right, but okay, yeah, that's true. But like in general, we do have the. This is
actually smaller than twice logarithm.
It can be almost that much if the log of something is just some integer decimal, a very small number like something like 2.003 or something like that. Then it is almost 2 times log n. Right?
So the bad case is if this number is power of 2 plus a little bit. If this is, let's say, 1 to 9, a little bit more than 128, then this is rounded by a lot on one hand, but on the other, logarithm of this is something like 7 points, let's say 101. It's get rounded to 8, but then it's not rounded twice up. It's only plus like 15%.
Okay.
So it's fine. And I think the worst case is if we deal with 3s or we deal with 5s. Log of 5 gets rounded up by a lot.
By the way, there's one more thing. The thing that I said is 2 log n. I think it's something else. Like the other log n is definitely smaller because like 1 log n is coming from the log base 2n, and the other log n is the number of total, like the sum of all the exponents of prime factors, right? So if we have the number as 2 to power something, then it is log base 2. Otherwise, it is definitely smaller.
But if we deal with big primes like 17, then 1 logarithm will be smaller.
Yes, exactly.
So yeah, this is log n plus log of what values we actually control. And so yeah.
Is there a theoretical bound on the number of prime factors of a number? I think it's just log n, right?
I mean, if you have multiple 2's
and
you count them separately, then it's log of n. And if you deal, and this is what we need in this problem, if we deal with something like that, I don't know if maybe it's called log star or something like that. I think there is a function for that. Okay. And maybe somebody in the chat knows. I don't remember.
Let me see the chat.
I don't know. There are different kinds of logarithm notations. There is some function for that. I just remember that it's always very small. Like instead of 20, it's maybe 7 or something like that.
Yeah, it must be very small.
Somebody primordial.
Primordial? Okay.
I don't know if that's the case.
Either way, we can see that this term is growing very fast. Like it's growing faster than factorial, actually.
I guess it's a reverse primordial.
Okay.
Yeah. So this magically works. We should also talk what happens with this GCD. So it's not trivial while some overseeing of that, because the actual solution, it needs to check all the numbers. We have those numbers, right? So we need to check all divisors of x and y.
Right.
If for every divisor we will do something like that, so for every x to check if it's good or not, we check its next multiple, y, and then we deal with this. Actually, then we will get the number of divisors from some logarithm, and the number of divisors is big. But for this, I thought about this visualization where if something, let's say that something is a form 3 to some power times 5 to some power, because this, then we can draw this thing in 2 dimensions, where one dimension corresponds to power of 3, the other is power of 5.
Okay.
So as the start, we know that there is true in top right corner, and then for every next cell, it's like this. Let's say that we have already some ones. For every next cell.
By the way, can I interrupt you for a moment?
Sure.
Yeah. So this looks really tough. What do you think should be the difficulty of this problem in terms of numbers? Around 2900 or something?
No. For sure, easier than 2900. I guess we can look how quickly people from the top solved it.
Okay.
And what it took them. 20 minutes is I guess the best score, up to 30 minutes. So it's like problem division 1 C or D in 5 problem contest. I don't know, what is that, 2500, 2400?
No, definitely not 2500. I almost always solve 2500 during contest.
Yeah, but here you didn't read it. Maybe you would solve.
Yeah, but you're explaining it. I'm not understanding most of the things. So, I mean, like I'm getting, but still it looks pretty complex. I don't think it's...
I think that during the contest, similar number of people solved E and F similarly quickly. So F isn't that much harder than E.
Okay. Or maybe people got stuck at C, that's why they didn't get the time to read both E and F.
I talked with Neil, who solved this very quickly, and he said that he actually didn't think a lot about the complexity.
Okay.
So that's also important. Like, we already discussed everything that is needed. And this table I'm drawing is just extra.
Okay, so this is like a proof.
Understand something.
Okay, right.
So like if you know that those numbers are good, and every cell, it actually represents number 3 to power of column plus times 5 to power of row, counted from bottom left corner. Then we deal with something like this. For a cell, we look for the next cell, like to the right or to the top. And we look at the division between them. Okay, in this case, the division is 3, and we have log of this. That's the number of queries we need. And then if this is yes, then because we know that GCD is always also yes, then we will also paint those cells automatically. So it's always when we paint something more to the left and we get 3 more queries, we paint this. When we paint something to the bottom and we get plus 5 queries, we paint this.
So why don't we
get this drawing rectangle?
Yeah, so why don't we just query over some 3 to power x and 5 to power 0, and then 5 to power x and 3 to power 0?
Because if it's 0, if the answer isn't positive, then you get nothing.
Okay.
Maybe you wasted the query.
Okay.
Because if this thing, the answer is 0, then actually we can cut out this whole part or something like that. And then we are left with this. So in 2 dimensions, if we deal with 2 prime factors, then the proof is very easy because it's like this coloring of rectangle. With more prime factors, it's just same thing, but with more dimensions. That's my proof. Maybe you can think about it easier. It's like why we don't do this for every divisor of n.
Okay.
But I don't think many people prove this during the contest. Even editorial doesn't fully prove it.
Even editorial doesn't prove it? Can we see the editorial?
The editorial says, you can look up the editorial. I think it says that later we will post the proof.
Okay, they'll prove. They'll post the proof later. Yeah. So I don't think it was very easy. I mean, 2500 isn't that difficult. I've seen a lot of 2500s, and yeah, it must be more than that.
We'll see, I guess, in a few days, because
Yeah.
when are difficulties posted,
Yeah, I think it takes around 3 to 4 days.
right? And we'll see.
But yeah, either way, I didn't get the chance to say how delighted I am to talk to you. Yeah. So I'm saying it now. Okay. And thanks a lot for coming here.
That's fine. That's fine. Guess we can do this.
I think Neil is in the chat.
future with some Codeforces, right?
By the way, I think Neil is in the chat and he's saying something about the proof, maybe.
So Neil says that he thought about it, but
Yeah, he intuitively decided that it must be pretty small.
but Neil, did you understand well why it is some of those logarithms? Because I think that understand well why we only for them do something, we need to make this kind of drawing. But I guess it was obvious why it's smaller than 4 times logarithm of n plus m.
Yeah, for 4 times that's
Seems-
fine. For 4 times that's fine. We can do it with that thing only, that 2 log n plus 2 log m, and then we can just combine them. Then we get 2 times log of m into n. That is definitely smaller or equal to the 2 times log of m square or something like that. Then we can take the 2 out. So we get 4 log m, which is obviously smaller than 4 log m plus n.
What do you think about the full problem set? Because I don't know all the problems.
Yeah, about the full problem set, if I talk about the problem C, I think the implementation was like really, I would say the word cancer. Okay. And then about problem D, like if you read it right now, if you read the problem D, you will solve it within like 5 to 6 seconds. It is just like the idea is.
Oh yeah. Gave a reach to problem D and it seemed difficult. I think I need some kind of dynamic segment trees where for every prime I want to add +1 to interval.
No, I mean like definitely it is like you will need some data structure, you'll have to figure that out. But the central idea, you can get that within 5 to 6 seconds, that you have to just maintain the minimum of all the prime factors, right?
But it's difficult. The data structure will be difficult because it's like exactly dynamic segment tree with adding to interval and taking minimum, right?
No, it's not dynamic segment tree. I mean, maybe it will work with dynamic segment tree as well. What I did was I just kept a multiset for all prime factors. I keep a multiset, and like for all the prime numbers, I keep a multiset of the frequency of all the numbers in that, like the non-zero frequencies of all the of that prime factor in all the numbers. I keep that in the multiset, right? And if the multiset has n elements, that means that this prime factor is non-zero in all of the numbers, right? And I just have to maintain the multiset.
Multiply Indian number.
Yeah.
Hey, I thought that we multiply interval of numbers by x.
No. We're only multiplying. We're only doing point queries, point updates. Yeah. So that's why it is really easy, right?
Now I see. Okay.
Yes.
Then I should read statements more carefully.
Yes.
Okay. Then I do.
Yeah. With the range queries, I think the range query version is not solvable, maybe, because the memory required will be just too much. That's what I think.
This is why I said we need dynamic segment trees, not full segment trees. So like
I think even with the dynamic segment tree, the memory requirement will be too much, because you see, for each node you make logarithmic of its parent nodes, right? So, and there are a lot of prime factors. So I think even with the dynamic segment tree, it will be like really difficult.
So it will be like q log square, right?
Right. The memory itself will be q log square, I think. So that's a lot according to me. I'm not sure.
200,000 times, like, let's say 200.
Yeah, that's more than
around 100 million. Okay, indeed, the memory is
Yeah.
just too little. Maybe we can fight with that.
yeah. But
seems
but,
more-
but for the point updates, that's like really easy. There's nothing there.
I agree.
Do read the problem C also.
This is
Yeah.
a bit longer, right?
By the way, in problem B, it is just implementation. It's nothing else. You can see.
It's-
I'll tell you the problem. It's just the clock, and you have to see whether the reflection is valid.
Okay.
Right. So just
So for every digit, we need to figure out if it's reversible or not.
like a little more than that. Like we have to tell the next moment of time, which will be like whose reflection will be valid. So we can just brute force for all the times. Like keep adding one, and yeah, that's it.
Right. Did you type by hand for every digit what its reverse, if it exists?
Exactly. I think there's no other way to do it because, like, how will your code know that 2 is the reverse of 5?
So, in some problems, you can just paste kind of this into a big array of Boolean values, like when you can type
Yeah,
hash,
exactly.
there's part of digits.
Yeah, I mean, exactly. That's what I did. I made an array and I keep the reflection of that digit in that array. And if the reflection is not possible, I keep -1.
Oh yeah, and I'm talking about something way more complicated and
What?
very annoying.
Yeah.
Like you can literally encode a string representation of everything to the dimensional thing, where like 0 we would represent like this hash, hash,
Okay,
hash,
okay, like a pretty print.
hash, not hash, and so on. So you could like literally print them, and so on. This is part of 0, and then you can check in automatic way what's.
So, but will that actually be quicker? Like if
Oh,
you write
not here, for sure not.
Okay, not here. Okay, in some problems, if in the statement only it is given like the hash and dots, then you can just copy paste it maybe. Okay. So if you see problem C, the idea is not that difficult. I mean, it took me some time to come up with it, but the implementation was really cancelled.
If the graph is smallest of length n, greater than this.
By the way, Neil in the chat is going to prove the 3 log n pretty straightforwardly.
Right? Isn't there some famous guy who gave a hypothesis that nobody until now can prove, and he just said that the proof is easy, like Riemann hypothesis or something like that, Goldman, something about
So
primes.
in the chat, Neil just said that CL of log p base 2 is smaller than 1.3 into log p base 2, and the worst case is for p equals 5. So I think then it is pretty straightforward, but I don't know how he will show that thing. Maybe you can just check for a lot of prime numbers.
Like starting, I showed you that if we have 7.01, this logarithm then shifted up to 8, the ratio isn't a lot, it's like plus 15%. So for sure we need to just deal with small numbers like 3 and 5.
Yeah.
They satisfy, then everything is fine.
Okay.
What Neil is saying, it seems reasonable.
Yeah. Okay, just checking for 2 to power k plus 1, the numbers of the form 2 to power k plus 1. Right. But then I wonder why
This
didn't.
problem what?
Yeah, but then I wonder why didn't they give 4 log n plus m in the problem? Like, is there any other solution that could have worked with the extra log m plus n queries that they wanted to fail intentionally?
I don't know. Maybe that, or maybe just they didn't think about giving a reasonable and easy to understand limit. Sometimes authors do that. They see that their solution works good enough, so they set this as limit instead of thinking how to set a proper limit so that for every person who comes up with a solution, it's obvious for them that it's correct. That's bad. Yeah, so in C, what we need to go like character by character from the left and decide in some way? How?
In this thing, in the problem C, yeah, I think there might be a greedy solution that you're talking about. I initially tried that, but I think the implementation there must have been like much more difficult than what I did in this one.
Right. So what it is if it's not greedy? Dynamic programming?
No. I mean, I'm pretty sure greedy would work here, but the implementation would be really difficult. What I did was I binary searched on the length of the common prefix. What? I couldn't hear you the last.
And then you have the character?
I couldn't hear the last thing that you said.
Because you also iterate over what is the next character after the prefix?
Yeah, after the prefix, I'll just iterate on the next character, and after that, I'll just fill it greedily, like with all the A's, and just satisfy the frequencies, the divisibility by K.
That's indeed a nice idea. I would, I guess, just try some greedy, and I would spend a few extra minutes on it.
But you see, instead, even in spite of using the binary search, it was like still really difficult because you have to build the string by like for the check function. What you want to do is you want to take the common prefix. After that, you will fill a lot of Z or Z, whatever it is pronounced in your country, and then you will print the remaining characters in the reverse sorted manner. After that, you will compare the two strings and see whether it is greater or not, and then only you have the check function. I don't think there's an easier way to do that one. And with the greedy, it is even tougher, I think.
But if you, I would say that your solution is pretty easy. Like mine is indeed complicated. If you have something like KA, 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 BC, and you say that this prefix should be the same,
yes,
and just here for the next position, try every character bigger than K. So L, M until Z or Z.
Right. Exactly.
Then whatever. Then you don't need to compare two strings, do you?
No, during the binary search, we have to compare, right? During the binary search.
Don't you just binary search the length of this prefix?
Yeah, so it's something like, can you make this a Jamboard so I can also draw on it?
It's complicated.
Okay.
You can as well make a Jamboard.
Okay, maybe I can also share my screen. I can share my screen maybe.
I see your screen on YouTube. You can just...
Okay, you can see my screen on the YouTube. Yeah, okay, yeah, that's better. Maybe I can just bring this board there. Just a minute. Okay. It's something like, right. Yeah, okay. That's kind of messy. And I want my viewers to see this thing as well, right? So it's something like I'm saying while checking during the binary search, I'm saying that this prefix is the same, right? So what I will do is I will make another string with the KA, right? And after that, I have to fill it with some ZZZZ, and I have to fill the remaining parities. I have to, satisfy them by filling K and A at the end. And then I have to compare it with the initial string, whether it is, greater than that or not, greater or equal to that or not. Because you could have
the one from the input?
The one from the input, right? Because the input string could be something like KA, and then you have all the only Z's, right? So if you try this thing, then obviously this is wrong. Are you getting my point? Because like if the K in the input is at least 3, right? If the K is 3, then you want all of these characters 3 times, right? So I have to put this K and this A at the end, and no matter how many Z's I fill, this will be smaller than the input string. So obviously it is not possible. So we have to build the string during the binary search to compare whether it is possible or not.
Okay, but to compare with the initial string, we just need to look at this character, right? If we put here something between A and Z, then it
No,
is
but what
greater
if
than
that
the
character
initial.
is Z? What if that character is Z? That's the case that I've shown you here.
Oh, I see.
Yeah, so what if that character is Z and a lot of characters to the right of it are Z? And that is the problem in the greedy solution. So it will get really difficult to do greedy because if the next character is Z, then a lot of the next characters can be Z, right? So for that, you'll have to maintain an array in which you're storing the next position that is different from the current character.
Okay, but wait. Something is wrong. If so, you're saying what if this character was Z from the very beginning?
Yes, like in the input. You can draw on your screen. It will be visible on mine.
Because then, if this is Z, then we don't consider changing this to anything greater.
Yeah, sure, but you cannot. But you cannot immediately tell whether this prefix will work or not because during the binary search you have to, you have to tell whether this will work or not, right?
Oh, so if you can just change to something greater like those characters, then it is not monotonic. It's monotonic only if we change to this character or greater. Need to binary search over that, is that right?
No, that's not what I binary searched on. I binary searched on the length that will be the same.
I'm saying that within that binary search, you say that K can be changed to K or something greater or just something greater?
It can be changed to K or something greater, but to be on the safe side, I just put Z's. Like as many Z I can put, I put as many Z's as possible. And after that, all the characters that are remaining. For example, I need 3 K's in the beginning. I need 3 A's in the beginning, right? So what I will do is, I know that I have to put 1 A and 1 K at the end, right? So I will put them in a reverse sorted kind of manner.
I get it. Okay.
Yeah.
Yeah, so it's more difficult than I would think.
Yeah, so I'll just create the greatest string. Basically, I'll just create the greatest valid string with this common prefix. And then what I will do is I will compare it with the string that was given in the input. And if that's actually bigger, then it works. Okay. Yeah, so now that you removed your OneNote, it looks really... Okay.
I see.
Yeah, you can remove it if you want. I can just erase everything. I can erase everything. I don't know how to do that.
I can do some stuff here.
Okay.
I see your screen with some latency. Yeah, it's not here.
Okay.
Oh no, you destroyed. I wanted to put this in some kind of circle that you had on your screen.
Yeah, you can make you can make your own circle if you want. Yeah. By the way, guys, sub to Errichto.
Right.
And if you're already an Errichto sub, you can sub to me also if you're interested.
Double subscription in price of one.
Okay. Yeah. Right. Okay.
Can you do anything more today?
Yeah. So now what do I do? Do I redirect everyone to your stream?
If you are finishing, then sure. If you're doing something else, then
I don't have anything else lined up.
Directly.
Like I should have gone to eat dinner like 1 hour ago, but yeah, here I am. Okay, so should I live redirect it to you? Can you give me the link to your stream so I can just redirect everyone there?
Give me 1 minute for that. This.
Wow.
So you guys, if you want to also be able to chat and comment, then you need to go to Twitch. Twitch link is this. Can I put? I guess I can just put a link here. But there is also something on YouTube.
I can automatically redirect everyone to the YouTube if you want.
I didn't know that that's possible on YouTube.
It's possible on YouTube. There's this feature called live redirect, and it is similar to the raiding on Twitch, I think.
But then I need to go live, and for this, Okay, so first I'm removing camera from here. So I need that in my OBS. I will start streaming. And wait, I'm starting.
Just give me the link somewhere on Discord or something.
I pasted in the chat.
Where did you send it?
It's somewhere in the chat.
Which chat?
Isn't it there? Maybe it was removed by a mod person.
No, I mean which chat? In the YouTube chat, I think links are not allowed.
Oh,
in the
YouTube. YouTube chat.
I think links are automatically removed in the YouTube chat. I'm not sure though.
You can go to my channel and there will be.
Okay, yeah, sure.
Something.
Yeah, but I don't want to open YouTube while sharing screen. Last time people were able to see my history, and yeah, that didn't go very well. Okay. I don't think you're live yet. Starting soon, okay?
I'm starting like in this second. I started a few seconds ago.
Okay, sure. I'll just live redirect. Yeah, you can see it here. There's this live redirect option. And yeah, so you can just.
Good to know.
Wait a minute, can I only redirect to my own videos?
Maybe.
Yeah, okay, so I'll just.
I thought that doesn't matter much. Just you guys, you can go to Twitch or just in Codeforces. There's.
Okay, I can't.
No.
That's fine. I'll just put this in the chat here. And I'll pin this so that people can go there. Okay. Cool.
Thanks for having me.
So thanks for coming. And goodbye.
Yeah. Bye.
How to connect this? Okay, so guys, we had Errichto today, and this was like really random. So this was like a big moment for me today, I think. Yeah, almost unbelievable. You guys want to know how it started, by the way? Is the chat frozen? Yeah, I really did get nervous. Do you guys want to know? Do you guys want to know how we got Errichto here? Does anybody wants to know how we got Errichto to come here? Okay, yeah. So it was something like, okay, yeah. So you can see, okay, yeah, somewhere here. So I don't know if this is visible or not. So Errichto texted me on CF, will you make your stream in English? He also wanted to cover it, but it is not nice to collide the strings. Collide the streams. So I said it is in English, but you can collide. It's fine. Nobody will watch me if you're also doing it. But then he said, what about discussing the hardest problem together? Right. So basically, what I said is, OMG, Errichto on my stream. Yes, sure. And yeah. So then it happened. Okay. Yeah, he was not few minutes late. He already decided to start from the problem from F, right? Okay, right. So that's what happened. Okay. All right. So thank you for watching. You guys can go over to Errichto's stream now, and okay, I think that's it for today. And good night, everyone. Now go solve F. Yeah. I'll see about that later. Maybe I'll leave it for some other day. And okay, yeah, it did seem really difficult to me, or maybe I was just really nervous because It was the first time I talked on voice to some such a legendary level competitive programmer, right? Okay. So thank you for watching, everyone, and good night.